Hello, this is Patrick at OneCNC West, and welcome to this brand new Problem Solvers video. In this video, we're going to take a look at a problem that comes up once in a while when you have a part that has similar holes at different Z levels. This is a great part for this. You can see that we have the exact same hole, 250 thousandths in diameter, with a small little 15 thousandths countersink there, and each one of those holes are also 250 thousandths deep. But they're all at different Z levels. You can see we have three different Z levels there. So how does OneCNC solve this type of problem? Well, there's a great tool within OneCNC called the Hole Wizard, and it does a great job of this. So what I'm going to do is I'm just going to pan this over just a little bit. Let's go over here to our main toolbar. Let's go into our stock toolpaths, and we're going to select our Hole Wizard. Now what the Hole Wizard does is it interrogates the geometry within your working area. This can be wireframe geometry, it can be solids, it can be surfaces, it can be a combination of all of that. And what OneCNC is doing here is it's taking all the items that it thinks are holes and it's putting them together into different groups. So as I left click here, you can see that the holes are placed into separate groups. Now even though all three of these groups share the same diameter and same depth, they're at different Z levels, and that's why they're in different groups. Well, I want to actually drill all of these, so all I need to do is just check all three of these items here. That looks great, and we'll click next on that. And what's really important here is that you want to check this item here called Use Geometry for Material Top. Because we have varying Z depths for the top of the holes there, you want to make sure you check that. Rapid plane, that's going to be used for all the holes. Same with the clearance plane as well. So all that looks good, and you can see there's little numbers here that help you reference or identify which each parameter is, which is also very nice. Let's click next on that. So what I'm going to do for all these holes is I'm going to drill. So I'm going to left click that. That adds it over here within the hole operations. And then let's also perform a countersink as well. So let's fill out the parameters for the drill. We're going to double click on that. And for the drill, we're going to say that's in turret position number 1. I'm happy with the RPM and feed rates there. Diameter looks good. The included angle, that all looks great. We'll just click next on that. What's really important here is where it says hole depth, you want to make sure that you have incremental selected. That means that the depth is going to be measured from each Z level. Okay, so we know that the hole depth here is going to be minus 0.25. That looks good. And I'm going to want to use a CAN cycle. So I have this machine cycle selected. If I had checked that, you would not get a CAN cycle. But I do want a CAN cycle. And because I checked that, I get to select what CAN cycle I want. And I'm just going to use a G81 for that. So we'll click Finish. And there we go. There's the drilling for all of those 1/4 inch holes at all those different Z levels. Let's perform the countersink now. So I'm going to double click that. Let's bring the parameter dialog box over here. Turret position number 2. Again, I'm happy with the speeds and feeds. I'm not going to change any of that. This all looks good. Oh, by the way, when you're setting up the taper angle here, this is not an included angle. The taper angle is measured from the side of the tool to the horizon, all right, to an imaginary horizontal line there. So that's going to be 45 degrees. Click next on that. So again, for hole depth, make sure that you have incremental there. We know that the hole is actually 250 thousandths deep. So if we want a 15 thousandths chamfer on there, all we need to do is put in minus. And the exact radius of the hole is 0.125, correct? And then if we want to go an additional 15 thousandths for that chamfer, just type in minus 0.015. And then if you hit the equal sign on the keyboard, OneCNC will perform the arithmetic or solve the equation for you. So anytime you have an input field within OneCNC, you can type in a formula, hit the equal sign, and bang, you're going to have the results right there. So minus 0.14 is what we want. We'll click next. Again, I'm just going to use a G81 CAN cycle. All that looks great, so we're going to click Finish on that. That looks very good. And then lastly here, let's finish up with a simulate. And I'm going to use the stock model I created earlier. Here are the holes being drilled at 250 thousandths deep. You can see it's using the clearance plane of 200 thousandths. That looks good. Let's zoom in on this just a little bit. Then it's going to drill the remaining 2 holes at that other Z level right here, 250 thousandths deep. And now we're going to put the 15 thousandths chamfer in there as well. I'm going to turn the back plot off. Just give us a little clearer view of the resultant toolpath there. And there you go. So problem solving. OneCNC does a great job of machining holes that are at different Z levels, and that's using the OneCNC Hole Wizard, which is available in every single mill system provided by OneCNC. All right, thanks again for watching. I look forward to seeing you in the next video.